I'm Anil Kumar. Welcome to my series on vectors. Here is Unit 1 test paper on Introduction to Vectors. We have taken up question paper from 2019, Calculus and Vectors, MCV4U. Here are all the questions from the test paper. Let me thank my student Gurmeen for sharing all these. You can always pause the video, copy the questions, try them out, and then look into my suggestions. So here is question number 1, which is true or false. You need to justify and reason out your answers, and then have a look at question number 2 and 3. Pause the video, copy, solve them, and then later we are going to solve them all one by one. Now these are the rest of the questions. There are 10 questions in this test paper. So I think you can see question number 4 to 8, and these are questions 8 to 10. Let us see how to solve these questions now. The very first question is on true or false. You need to justify your solutions, reason them out. The very first one is part A. A vector is a quantity that has only magnitude or direction. This statement definitely is false. It has both, not or. This is not only. The vector is a quantity that has both magnitude and direction, right? So that is the correction. Part B. A unit vector divided by its magnitude, is a vector of length 1 in the direction of non-zero vector. That is true. So when you divide the magnitude, when you divide by the magnitude, you get one magnitude, right? Direction remains same. Opposite vectors don't have equal magnitude. This is false. They have equal magnitudes, right? Right? Part D is, if magnitude of A is equal to magnitude of B, then the vector A equals to vector B. So whenever I'm writing in bold, it is a vector, arrow on the top is a vector. So these two vectors should be equal if their magnitudes are same. This statement is false since they can have different direction, right? Part E. When two opposite vectors are added, the resultant is a zero vector. That is correct. If two vectors u and v are parallel and in the same direction, then u plus v, the magnitude, is less than magnitude of u plus magnitude of v, and u plus v is in the same direction as u plus v. Later half is correct. However, let's say if they are in the same direction, let's say this is u, this is, let's say, v, they are in the same direction, then their magnitude is not less than but equal to, right? Therefore, the statement is false. The last one here is m plus n a. So when we write like this, it is a scalar multiple, right? So this is a scalar multiple. Equals to ma plus na is associative law for vectors. This statement is false. It is associative law for scalars. Is that clear to you? So that is how you can actually answer the very first question. Now let's look into question number 2. Part A is, name a single vector equal to pt minus qt minus rp plus rq. Whenever you have such kinds of question, it is a good practice to write all with positive, right? So we could write this as pt. So if I have to make negative as positive, I have to change the direction. So it becomes plus TQ, right? Here this becomes plus R, P becomes PR. So plus PR, and then here we have RQ plus RQ. So here you have P to T and T to Q. So these two can become P to Q, right? Plus P to R, R to Q is also P to Q. Right? So these are the vectors, P to Q. Let me write like this. So we get P to Q plus P to Q, which is equals to 2 times P to Q. Is that clear to you? So that is how you could actually solve this question. Question 2b. In a trapezoid ABCD, AB equals to 2 times DC. So AB is twice in length, but in the same direction. These are vectors. If the diagonals meet at O, find an expression for AO in terms of AB and AD. So let's sketch. So let's say this is our AB and it is twice DC. So let's make a isosceles trapezoid, kind of. This is half of this length, right? Now we can just join the sides. We're talking about intersection of diagonals. So these are the diagonals. We are given trapezoid AB, CD. So let's label this as A to B to C to D. Now, when we say AB is twice DC, that means these are the two parallel sides we're talking about. And the length AB is 2 times DC, right? This is the point of intersection, which is O. Now, if you look into the triangle AOB and triangle now COD, these two are similar triangles, right? Since these sides are parallel, we have opposite angles. Angle COD is congruent to angle AOB, and the other angle, that is an alternate angle, right? So the angle, you can say OAB is congruent to OCD. So they are similar using the property of angle. Okay. Now if they are similar, then the sides are in the same ratio. So we know AB to DC is 2:1. That means that AO to OC is also 2:1, right? So this is also 2:1, clear? So that is important to understand. Similarly, DO to OB will be 1:2, right? This is 2, right? Okay. So we are going to use this particular property of similar triangles to find out the relation. Now we need to find an expression for A to O. So A to O is 2/3 of A to C, right? So we can write A to O is, if it is 2, this is 1, total is 3. So A to O will be 2/3 of A to C. Now A to C can be written as AB. You can say AD plus DC, right? So we can go like this. Since we have to write in terms of AB and AD, so we'll write this as 2 over 3 times A to C is A to D plus DC. So we have AD in our expression. Now we have to replace DC with A to D. So DC is half of AB, right? So we can write from here half of AB is DC, right? Substituting this here, let's call this equation 1, and we'll sub equation 1 from 1. DC is half of AB. That is given. Correct? Now if you open the bracket, you get 2 over 3 A to D, and that 2 and 2 cancel, so we get plus 1/3 of AB. And therefore we get now a relation of AO as equal to 2/3 of AD plus 1/3 of A to B. Clear? So that is how you're going to show this. I hope the steps are absolutely clear. Let's move on and take question number 3. Question number 3A. Given the parallelepiped as shown, state a single vector representing DG plus FE. So from D to G, we go like this, okay, right, DG to FE, and we have to add FE. FE is parallel to GH, correct? So we can write this as DG FE is parallel to GH, so we can write GH, parallel and equal. So that becomes D to H. So clearly that is equal to D to H. Correct? The second one here is relating AB, A to D, and A to E, relating these three, correct? So we could go like this, A to B, this is parallel, so this side equal and parallel, so it will be C to B to C, and then from C to, we are going in this direction, G, right? So effectively, we could go like this, this is parallel, right, and equal, and then this will be kind of like this. Do you see that, right? So we'll write this as A to B. AD is same as BC, and AE is the same vector as C to G. And therefore we get A to G as our answer. Clear? Question 3b. If the coordinates of C, D, and H are -5, 8, and 4, so C is -5, 8, and 4. D is 2, 5, 3. D is 2, 5, 3. And H is 2, 0, 3. H is 2, 0, 3. Determine the coordinates of G. We need to find this. Let it be X, Y, and Z. So from here, we know that GH is equal to DC. Okay? So, sorry, HG, we wrote HG and DC. Okay, that's fine. So HG is equal to DC. So that means we could write like this, that XYZ minus 203 is equal to DC means minus 584 minus 253. Right, so we can write this as XYZ yz is equal to, let's do this and then take it to the right side. So minus 5 minus 2 is minus 7. 8 minus 5 is 3. 4 minus 3 is 1. And we'll add this, which is 203, correct? So we have the vector x, y, z, this is a position vector, is equal to minus 7 plus 2, which is minus 5. 3 plus 0 is 3. 1 plus 3 is 4. Right. So from here, we get the values. So we get x, coordinate is minus 5, y is 3, and z is 4, correct? So our answer, as shown here, is minus 5, 3, 4, correct? So that becomes the solution. Here is question number 4. Copy the three given vectors a, b, and c. Then accurately draw d, which is half of b plus a minus 2c. So let me just sketch the three vectors. Well, let's say this is one of the vectors. Let's call this as vector b. And then here we have a vector which is a, and the vector c is given in this direction. Okay. Now we need to find what is sum of these three vectors. So when we say half of b, that means that is going to be half of b, right? And parallel. So we can begin with this. So that is half of b. Plus a, so this is a for us. We can place it here with the tail at the head. Same length and same direction. So that is a. Minus 2c. C was going in this direction. Minus 2c will be actually twice the length like this. Right? So that is minus 2c. So we'll put it here, minus 2c. Correct? Now joining from the starting point to the end point gives us the vector d, right? So now we'll join from here to this point. That becomes our vector d. Clear? So that is how we are going to sketch it. So I hope the steps are absolutely clear. So normally this will be given to you on a graph paper where you can accurately sketch. Question number 5. Given 2 times x minus y plus z equals to 0 vector, and x vector is given as 1 minus b c, y is ai minus 7k, and z is 3a01, determine the value of unknowns. That means you need to find what is a, what is b, right? And what is c. Okay, so we'll begin with what is given to us, which is twice x minus y plus z equals to 0 vectors. So x, y, z are the vectors, where x is 1 minus b, c. So let's rewrite this as twice. We have 1 minus b, c minus y, which could be written as a0 minus 7. a0 minus 7 plus z, which is 3a 0, 1, and that is equal to 0 vector. That means 0, 0, 0. So that gives us twice 1 minus a, and this is minus b. C minus minus becomes plus, so it becomes c plus 7. And here we have plus 3 a0 1 equals to 0, 0, 0. So that is 2 times a. You could write this as twice 1 minus a minus 2b, and this could be written as 2c plus 14, right? 2 times 7, 14. plus 3a 0 1 equals to 0 0 0. Now we can combine these terms. These are the two vectors. So it is 2a minus 2a plus 3a. Then we have minus 2b, and we have 2c plus 14 plus 1 is equal to 0 0 0. Now this is 2, right? So 2 minus 2a plus 3a. So that gives, we can now equate, so we get one equation which is 2 minus 2a plus 3a is a, 2 plus a equals to 0. Here we get minus 2b equals to 0, and there we get 2c plus 15 equals to 0. So from here we get a equals to minus 2, b equals to 0, and c equals to minus 15 over 2. Correct. So that becomes the solution for us. So we have our answer, which is a equals to minus 2, b equals to 0, and c equals to minus 15 over 2. Correct. Let's take question number 6 now. If the magnitude of vector A is 4, magnitude of vector B is 9, and the angle between A and B is 60 degrees, determine 2A minus B. Okay. So let's define a vector A and B. So let us say this is our vector A, and this is our vector B, and the angle between the two is 60 degrees. This magnitude of vector A is 4, and this magnitude of vector B is 9. That is the given situation. Now, when we are combining, we want to find what is 2A minus B, right? So let's sketch 2A minus B. So basically, minus B will be in that direction, right? So what you could do here is, you can say this is 2a, right, twice the length, and minus b will be in this direction. Now, earlier it was here, right? So the earlier angle, this was 60 degrees. Now, since these two sides are indeed parallel, this is also 60 degrees, right, opposite. So what we have here is twice a, that means 8 magnitude, and this is 9, right, but in this direction. Is that clear to you? The answer which we are looking for is the resultant, which is this. This is what we need, which is 2a minus b. Good. Now we can use cosine law to find the magnitude of this side, and then we can find its direction with one of these angles, right? We'll find with a. So let's first use cosine law. So the magnitude of 2a minus b whole square will be these two sides magnitude, 9 square plus 8 square, minus 2 times 9 times 8 times cos of angle between them, which is 60 degrees, right? So let's calculate. So we have 9 square plus 8 square minus 2 times 8 times 9 times cos of 60 degrees. That gives us 73. So we get 73. So the magnitude of 2a minus b will be square root of 73. So let's do square root of our answer, which is in decimals 8.544, right? Or we can say square root of 73, right? So that becomes the magnitude. So now we know that this side here is square root of 73. we need to find the angle. So let's find this angle as theta, which it makes with A, right? To find that angle, we can use sine law, since we know a combination of side and opposite angle, correct? So let's use sine law to find this angle, theta. So we can say sine theta over the side opposite, which is 9, is equals to sine of 60 degrees over this side, which is square root of 73. Clear? Now it's good to use square root 73 since we get more accurate answer, right? So we can get sine theta equals to 9 over square root 73 times sine of 60 degrees. So 9 divided by square root 73 times sine of 60 degrees. We get this as equal to, so we have sine theta equals to 0.9122, let's say 5. So theta equals to sine inverse of this value. So we'll shift sine inverse of our answer, and that gives us a value of 65.8. Okay? So to three significant places, theta angle is this. So we have our answer, and that is the vector 2a minus b has magnitude of, you can say, 8.54 units and 65.8 degrees to vector A. Clear? So that is how we can describe this. You have to find both magnitude and direction when we say determine 2a minus b. Question number 7. If magnitude of A is 11 and magnitude of B is 23 and A minus B is 30, find what is A plus B. Right? Now, so in this case, what we could do here is, one, let's understand the situation. Let us say we have a vector A here and vector B there, right? Let us see. So these are the two vectors, A and B. Let's say this is vector A, this is vector B. So when we say A minus B, so A minus B will be this vector, correct? But when we say A plus B will be that vector. So this vector is vector A plus B. You get the idea, right? And A minus B is this vector. So that is how the vectors are when you make a parallelogram. Correct? So we are given the magnitude of A minus B. That means we are given this particular magnitude. We know these two magnitudes also. Now, since this is a parallelogram, we know that the angle between these will be by a difference of 180 degrees. Correct? So that is a very important property which we could consider and then find our solution. That is one way we could do it, right? Algebraically, what we could do here is that think like this. Think like this. If I have two vectors A and B, right? So in this situation, let's say this angle here is theta, and this angle here will be, because that is, this angle will be 180 degrees minus theta, correct? So if you look at it, magnitude of A minus B basically will be equal to magnitude of A square plus magnitude of B square minus 2 times magnitude of A, magnitude of B, cos of angle between A and B, which is theta for difference, correct? That is going to be the square of this. On the other hand, the square of magnitude of A plus B will be magnitude of A square plus magnitude of B square minus 2 magnitude of A times magnitude of B times cos of 180 minus theta. Now cos of 180 minus theta is minus cos theta, so this could be written as magnitude of A square plus magnitude of B square plus twice magnitude of A magnitude of B cos of theta, correct? Now from equation 1 and 2 we'll derive our equation and then solve, right? You could have actually used the formula directly also. So when you add these two, what do we get? We get magnitude of A plus B whole square plus magnitude of A minus B whole square is basically equals to twice magnitude of A square plus twice magnitude of B square. These terms cancel, right? We need to find what is the magnitude of A plus B, right? So we get magnitude of A plus B whole square equals to twice magnitude of A square plus twice magnitude of B square minus square of the difference between their magnitudes, right? So this expression is equals to twice A is given to us as 11 square plus twice 23 square minus 30 square, correct? So we can calculate this value, which is 2 times 121, which is square of 11, plus 2 times, let's write within brackets 23 square, minus 30 square. So this is 400. So magnitude of A plus B is basically square root of 400, which is 20, correct? So the important formula which we learned here in this exercise is that you could actually find magnitude of A plus B whole square as magnitude of A square twice plus twice magnitude of B square minus magnitude of A minus B whole square. So you could use this formula to calculate answer for such questions, right? So I hope that is absolutely clear. Now let's take the next question, which is question number 8. It says, given the vector OA 1, 3, minus 2, plot OA in R3. If OB is 2, 4, 1, determine A to B. Find a unit vector in the direction of AB. So let's first sketch OA. So in R3, we have axis x, y, z. They're orthogonal to one another. OA is 1, 3, minus 2. That means along the x-axis, we have to go 1 unit, 3 units along y, and minus 2 means along z minus 2, right? So 1 unit along x. So let's say this is 1 unit, right? So that is 1. 3 along y. So 1, 2, 3, right? And then minus 2 means go 2 units down. So that is the vector which will be shown like this. Is that clear? So that becomes our vector OA. So that's part A. B. OB is 2, 4, 1, determine AB. So AB will be equal to, we can write in this form 2, 4, 1 minus A to B, so B minus A, right? So 1, 3 minus 2. So basically AB is OB, what we have done here is basically OB minus OA, right? That is AB. Okay. So we get here 1, 4 minus 3 is 1, 1 minus 2 is 3. So the vector OAB is basically 1, 1, 3, correct? Now we need to find unit vector in the direction of AB. So let's find the magnitude of AB first, which is square root of 1 square plus 1 square plus 3 square, which is equal to square root of 1, 1, 2, 2 plus 9, 11. So that becomes the magnitude of AB. So when you do part C, that is magnitude unit vector, which could be written like this. Unit vector AB will be the vector AB divided by its magnitude, correct? So in our case, it is equal to 1 over square root of 11, and the vector AB is 1, 1, 3, correct? So that is how you could write the unit vector. So the unit vector AB, which is normally represented by this, right, that becomes unit vector, will be 1 over square root of 11, 1 over square root of 11, 3 over square root of 11. Clear? So that is the unit vector AB. So I hope that is absolutely clear. Now last two questions, let's move on and complete our test paper. Question number 9. Determine whether the points P, Q and R represent vertices of right triangle. So in that case, let's find the side lengths. So let's find what is PQ. So PQ will be 1 minus 3, 2 minus 0, 5 minus 4, which is minus 2, 2, and 5 minus 4 is 1. So the magnitude of PQ will be square root of this square plus that square, that is 4 plus 4 plus 1, which is 9 square root, and that is 3, correct? Okay. Now let's find what is QR. Now QR will be 2 minus 1, 1 minus 2, and 3 minus 5, which is 1 minus 1, 2 minus 2. So the magnitude QR is square root of 1 plus 1 plus 4, which is square root of 6. Now let's also find P to R. So P to R will be 2 minus 3, 1 minus 0, and 3 minus 4, which is minus 1, 1, minus 1. Or magnitude of PR is 1 plus 1 plus 1, which is square root of 3. Now from here, we see that PQ square is equals to these two squares, right? 6 plus 3 is 9, right? This is square root 9. So we see that PQ square is equal to QR square plus PR square. Right? This is 9, and these two are QR is 6, and this is 3. Good. So that means we're talking about a right triangle where PQ is the hypotenuse, right? So square root 6, let's say this is square root 6, this is square root 3, and this is 3, this is P, Q, and here we have R, right? So that is the right triangle we're talking about. So we've shown that yes, triangle PQR is a right triangle. Clear? Now part B of this is to find cosine of angle PQR. So cos PQR, this angle we want, right? So cos of angle PQR is adjacent over hypotenuse, is QR over PQ, which is square root 3 over 3. Okay, so that is the answer. Sorry, QR is 6. Sorry, this is 6. Sorry. QR is 6. So square root 6 over 3. Sorry. So QR is longer. It is 6. I made it wrong. Anyway. So the angle here is square root 6 over 3. Clear? So that is how we are going to answer this question. Let's take up the last question now. Question number 10. If magnitude of AB is 7, we are given the diagram here. A to B is 7. BC, B to C is 6. A to D is 9. And the angle between AB and BC is 100. So this angle is given to us as 100. And the angle between AC and AD, AC and AD is 35. This angle is 35 degrees. So that is what is given to us. What is the magnitude of AC? So we need to find magnitude of AC. Okay, we can apply the cosine law and find it. What is CD in terms of, so we need to find what is CD in terms of AB, BC, and AD. Okay. So let's begin with part A, which is to find AC. So using cosine law, you can find this answer, right? So we have AC square, magnitude, let me write, equals to 7 square plus 6 square minus 2 times 7 times 6 times the angle between them, which is cos of 100. Is okay? So let's calculate. So we have 7 square plus 6 square minus 2 times 7 times 6 times cos of 100 degrees. That is 99.58. So the magnitude of AC will be square root of this. Okay. Let's do square root of our answer is 9.979. So we can write this as 9.98. Right. So 9.98 units is AC. Now let's do part B, which is what is CD in terms of AB, BC, and AD. So C to D we have to find. Okay. So C to D we need to find in terms of AB, in terms of AB, BC, and AD. Okay. So we know AB plus BC plus CD plus DA, or you can say is equal to AD. You can write this as equal to AD. So all this will be equal to AD, right? You could write like this. And then we can find what CD is by taking these things to the right side. Perfect. So from here we get CD is equal to AD minus AB minus BC. Correct? So that becomes our solution. So with that, we complete the whole test paper. I hope you find it interesting and useful. This is indeed a very good paper to start with. So here are the questions which we just solved. Multiple reasoning questions for true and false, and basics about vectors. Now, since this is a real test paper, it should really help you to get very good marks in this paper, MCV4U vectors. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.